Okay, hello, Math 112. So what I want you to do is pause the video, try to solve this problem, and then press play and see if it matches my solution. There's only going to be three problems. And remember, your final is Wednesday and Friday of this week. So we're solving a logarithmic equation. So we're finding x, and logs are exponents. So when you subtract exponents, you must have divided the power. So we can combine these two logs into one log as long as we divide these powers. And then at this point, we have one logarithm that equals 2. So logs are exponents. 2 is the exponent on base 7 that would equal this. And of course, 7 squared is 49. Multiply both sides by x plus 4. We distribute that 49. We subtract x. We subtract 196. And lastly, we divide. So x is negative 197 over 48, which is about negative 4.1. So that is our answer. And that's a fine answer. It's negative. This shouldn't be a problem. The only problem we have to realize or think about is back in the original, logs can only receive positives. They can only receive positives. So our answer algebraically is negative 4. So when we plug in negative 4 into this x, it's game over. And that means there's no solution because negative 4 minus 1 leaves us with negative 5. And the log base 7 of negative 5 is not it just is undefined. Logs can only receive positives because logs are the inverses of exponents, and exponents, the exponential function can only produce a positive. The range is a positive. So the domain of a log, it can only receive a positive. So this is kind of shown here. When you replace x back to the original with negative 4, both of the logs fail. Negative 4 minus 1 is negative 5, and negative 4.1 plus 4 leaves you negative 0.1. So it's still a negative. So this one has no solution, which is the correct interpretation of this problem. What about this one? Pause the video, please. Try to solve it. Here's another log equation. These two logs are being added. So the property for adding logs is that you multiply the powers, because back in Algebra 1, when you multiplied two powers, you added the exponents. And remember, logs are exponents. So we got a binomial times a binomial. We've got to do some double distributing. We get this trinomial. And then now what? Well, logs are exponents. So 1 is the exponent on 4 that results in this. So 4 to the 1 equals this. Be careful you don't write 1 to the 4. 4 is the base. 1 is the exponent. And of course, 4 to the first power is 4. We're going to subtract 4 on both sides and get a quadratic that equals 0. This is great news because you can always do quadratic formula when you have a quadratic that equals 0 and be done. You are expecting two answers here. This one actually factors, but quadratic formula is totally fine. You would get the same two answers in both cases. You would get negative 1 as an answer. Again, nothing wrong with that. And you would get 13/4 as an answer. Nothing wrong with that. Or so we think right now. We have to check it in the original. When we plug in 13/4 into the original problem, do we end up with positives here? It can't even be 0. It has to be positive. Well, 13/4 minus 3 is positive. It's positive 1/4. And 4 times 13/4, the 4's cancel out, leaving you with 13 plus 3, which is positive 16. So 13/4 is a winner. Negative 1, however, is not, because right away, negative 1 minus 3 is a loser. And you cannot take the log of a negative. But I want to just be clear here. Your answer, when you're solving log problems, x can be negative. X can be negative. The problem is when you plug it in, if the result is a negative, then you've got a problem. And so there's only one answer here, which is 13/4. Third and final problem. Please read the question, pause the video, and try to solve this one. So we've got a phrase we haven't heard in a while. To vary jointly means that two or more things are being multiplied, two or more. And they should be listed right away. And there are just two, y and z are being multiplied. So the numerator, remember k, you always need k. K is the flexing part of the equation. It's they call it the constant of variation, but it's what makes two different things that vary jointly different. The k could be any value. And inversely, if it varies inversely, that implies division. Well, inversely to what? To the square root of w. I noticed this before. Some people would write down w squared right here. We have to be careful. The square of w is w squared. But the square root of w is this is the square root of w. So that word root is important. Be careful. So now what? Well, we know that when y is 4, so I can replace y with 4, z I can replace with 3, w replace with 25, and x with 75.6. So I know y, z, w, and x. I can therefore find k. And that's the first thing we need to find. So the square root of 25 is 5, 4 times 3 is 12, multiply both sides by 5, divide by 12. So k is 31.5. So this is the equation with all the color in it, with all the numbers in it. And now that remember the final question was, what's y? When x is 42, when z is 2, and w is 9. Well, now we have the formula, so we just replace w with 9, we replace z with 2, and x with 42, and we just solve. So red 9 is 3, so I'm going to multiply both sides by 3. That gives me 126. 31.5 times 2 is 63. Divide both sides by 63, and we get our final answer. Y equals 2.